Hello, Year Nines. This is Mrs. Elliott. I thought rather than having a lovely view of my face for this demonstration, it would be much better if you had a view of my hand showing you how to do some upper and lower bounds questions. So this is basically part of your homework on measures and accuracy, which is section 9.3 of the book. And this is probably the bit that's the most complicated. So I thought it would be useful to do it as a demonstration. So in your books, and remember you can pause this at any time so you can use it to just take notes, write a title of upper and lower bounds. Now, as you know, any number, when it's given to a certain degree of accuracy, has been rounded. And what we say when something has been rounded is that it is correct within a certain error interval. So error intervals could also be the title of this work. So it's upper and lower bounds or error intervals. Now you're probably wondering what the hell I'm talking about at the moment. So I'm going to give you an example of something. If we've got a book and it is measured as 16 centimetres to the nearest centimetre, the question is, what is the smallest it could be? And what is the largest it could be? So let's just think about this 16 centimetres. So here's our number line, and there's 16 centimetres. You could think of this as a ruler if you like. 17 centimetres is up there, and 15 centimetres is down here. Now we know that the book has been measured to the nearest centimetre. So what we're interested in is how small it could be and still be rounded up to 16 centimetres. Now we know that we round, if we're rounding to the nearest centimetre, if something is 15.4 centimetres, we will round it down. If something is 15.9 centimetres, we would round it up. What is the smallest number that we could round up to 15 centimetres? Well, the smallest one that we would round up is 15.5 centimetres. So we call our 15.5 centimetres our lower bound. 15.5 centimetres is our lower bound. Then the question is, what would be our upper bound? So thinking again about 16 centimetres, which is what the book has been rounded to, if the book was 16.1 centimetres, we know that it would definitely be rounded down. If it was 16.8 centimetres, we know that it would definitely be rounded up. The point at which it shifts from numbers that are rounded down to numbers that are rounded up is 16.5 centimetres. At 16.5 centimetres, we would round up. But anything just below, literally just below, so 16.499999999 centimetres, we would round down. So we say that our upper bound is actually 16.5 centimetres, but look carefully. I am putting my inequality signs so that my book could be 15.5 centimetres and equal to 15.5 centimetres or above it, and it would round up. But with the 16.5 centimetres, I've got an inequality sign that doesn't have an equal sign, which basically says that the book can be anything up to 16.5 centimetres, but not quite 16.5 centimetres. So 16.5 centimetres is my upper bound, but my book measurement never quite reaches that, otherwise it wouldn't be rounded to 16 centimetres to the nearest centimetre. Let's have another example that you could also copy down, just to have a little bit more of a think about how these upper and lower bounds work. So, in your textbooks on page 176, so textbook, page 176, there is an example right at the bottom of the page of a mass of a meteorite, which I can't spell, meteorite, and it's given as 235.6 grams to the nearest gram. No, actually not to the nearest gram, to the nearest 0.1 of a gram. Now, it doesn't say what it's rounded to in the book. It just says the mass of a meteorite is given as 235.6 grams. But we know that it's been rounded to 235.6 because that's what it's been stated as, okay? So here's our 235.6 grams of a meteorite, okay? Again, if you want to, you can think about your number line. So 235.6 is there. So the next decimal to one decimal place up would be 235.7. And the one before it would be 235.5. Now, this interval here, if we split it in half, and this interval here, if we split it in half, will give us the lower and the upper bounds between which our measurement must be rounded to 235.6. So think about what these two measurements are going to be here. This one is halfway between 235.5 and 235.6. So it's actually going to be 235.55. And the one over here is 235.65. Now remember what we said. 235.55, if the measurement of the mass of the meteorite was exactly that, it would round up to 235.6 to one decimal place. For the 235.65, that would actually round up to 235.7, but anything up to it would round down. So if it was 235.649999999, it would round down. So as long as we put our inequality in, so that it's a less than on that side, so we know it can never quite get to 235.65, and as long as we have our inequality including the 235.55 on this side, then we've got our upper and our lower bounds for the mass of this meteorite. And that upper and lower bound are often called upper and lower bounds, but also, as I also said, that could be described as the error interval for the mass of the meteorite. So these inequalities are important. It helps us to understand that at the upper bound, we're going up to 235.65, but we're never quite reaching it because we don't put the equal sign in there. At the lower end, though, 235.55 is the lowest mass that would round up to 235.6, and therefore the equal sign is justified there. Okay, I'm going to do a few more examples for you, gents. So let's just do them one at a time, and you can write them down as we go along. So the first one, I've got the number 3,400, and it is to the nearest 100. and I want to find the error interval, or the upper and lower bound. So 3,400 there. And I'm going to put in my inequality signs ready. If you like, we can still think about the number line. So 3,400 on the number line. We're going to the nearest 100. So 3,500 would be the next one up. And 3,300 would be the next one down. We look at the error intervals on either side and we split them in half. Sorry, not the error intervals, the intervals on either side, and we split them in half. Our lower bound is going to be 3,350, and our upper bound is going to be halfway between there and there, 3,450. So we basically look at this number here, we split it in half, 50, we go 50 on either side. Let's have a look at another example. Example 2. So this time I've got 32 centimetres to the nearest centimetre. So here's 32. I'm going to put my upper and lower bound inequality signs in. I am drawing myself a number line. There's 32. The next one up will be 33. The next one down will be 31, because I'm going to the nearest whole centimetre. So I'm going to go halfway between them. So 31.5 centimetres on that side and 32.5 centimetres on that side. Yeah? Okay, I'm not sure if you can completely see my board, so I'm going to just move on to example 3 by rubbing these off. Okay, remember you can pause at any time so that you can note things down. So just again, remember we've got our whole centimetre on either side. We're going to split that in half. Half a centimetre on either side gives us our upper and lower bounds, or our error interval. Next one. Example 3. I'm going to go for 300 to one significant figure. Now, think about significant figures. Significant figures are the number of numbers, effectively, that you're putting in your number after the first zero. Well, there is no first zero here. Our first significant figure is in the hundreds column. So to one significant figure, we're talking about to the nearest 100. I'll just do what we do at primary school, hundreds, tens, units, yeah? Our first significant figure is in the hundreds column. So we're looking at 300, and the next rounding up would be to 400, and the one below it would be to 200. So again, splitting those intervals down the middle, we're going to have 250 and 350. So our upper and lower bounds for this 300 to one significant figure going to be 350 and 250. Example 4. Example 4, going to go for 23.8, which has been rounded to one decimal place. So 23.8, put in my inequality signs, think about my number line. I'm going to one decimal place on either side. So 23.9 there, and it will be 23.7 there, splitting those intervals in half. The 0.1, one decimal place is 0.1, remember. So 0.1 on either side. This is going to be at 23.85, and this one is going to be at 23.75. 23.85, 23.75. I think you can probably see how these are going. We'll just do another example. This time we'll do an example where the number has been rounded to two decimal places. Okay, so I'm rubbing off. Remember, you can pause if you're not ready. Okay, example number 5. So So with example 5, I've got 7.89, and that has been rounded to 2 decimal places. So second decimal place is in the hundredths column there, isn't it? Yeah. So let's just have a think about what that's going to look like. I'll just write it out ready to go. Number line. So we're at 7.89. We're rounding to 2 decimal places. So the next one along the number line would be 7.90 to 2 decimal places. And in the other direction, I've got 7.88 to 2 decimal places. Yeah. Thinking about those intervals, splitting those intervals in half. This top one's going to be at 7.895, and this lower one is going to be at 7.885. And again, 2 decimal places, that's my hundredths column, isn't it? If you think about it, I've taken my hundredths and I've split those in half. So my hundredths, splitting those in half, has given me 5 in the thousandths column on either side. But from my number line, you can see clearly 7.895 as the upper bound and 7.885 as the lower bound. And that is therefore my error interval. Now, last thing just to think about on this section. Everybody, remember, you can pause because I'm about to rub this off. Last thing to think about on this section is that some of the questions you've got are going to be talking about units of measurement, just like the very first examples I looked at were. So we'll just have a look at a few examples, just thinking about rounding to the nearest 5 millimeters. So we're going to do all of these examples rounding to the nearest 5 millimeters. So that's going to be for all of these. So example 1. So I've got 55 millimeters and I want to find the upper and the lower bound for that. Okay. So thinking about 55 millimeters here, that has been rounded to the nearest 5 millimeters. So the one next up the number line would be at 60, and the one below that on the number line would be at 50. Take your intervals here and here. Think about how big they are. On this occasion, they are at 5 millimeters and 5 millimeters. So we're going to split that in half, and that on this occasion is going to give us, I'll change colour pen, is going to give us 57.5, halfway between 55 and 60. And here I'm going to be at 52.5, again halfway between 50 and 55. So my upper bound is at 57.5 and my lower bound is at 52.5. So that's an interesting, slightly different version of the rounding, because we haven't got an interval that's got a sort of a 0 on the end of it, a 10 or 100 or something like that. It's a 5 interval, yeah, 5 millimeter interval in this case. But the idea is the same. Split that interval in half, and then you're adding 2.5 on this side, taking away 2.5 on this side. Okay, so still thinking about rounding to the nearest 5 millimeters, we're going to have a look at 34 centimeters. So this is a bit harder. So 34 centimeters, I'm going to put there. Now, thinking about the next one up, if we're adding 5 millimeters, that's 0.5 of a centimeter. So that's going to take us up to 34.5 centimetres. Taking away 5 millimetres, we're going to be down at 33.5 centimetres there. Yeah, so still remembering that our distance here is 5 millimeters, and here is 5 millimeters, but my units have changed to centimeters this time. So I've put it as 0.5 of a centimeter. Halfway points. Halfway between 34 and 34.5 is 34.25 centimeters. Halfway between 33.5 and 34 is 33.75 centimeters. So we're going 2.5 millimeters in each direction. 2.5 millimeters in each direction is 0.025 centimeters in each direction. 34.25 centimeters is my upper bound, and 33.75 is going to be my lower bound. Final example. Guess where we're going with this? We're getting bigger with our units each time. 0.3 meters, but now with my 0.3 meters, I'm still looking at rounding to the nearest 5 millimeters. So 0.3 meters is there. And then thinking about each side of this. So 0.3 meters, add 5 millimeters to that, and I'm at 0.305 meters in that direction. Take away 5 millimeters in this direction, and I'm at 0.295 meters in that direction. Yeah, so just think about it. So 10 centimeters is 0.1 of a meter. 1 centimeter is 0.01 of a meter. 1 millimeter, I'll write it over here, 1 millimeter equals 0.001 of a meter, doesn't it? Yeah, there are 1,000 millimeters in a meter. So 0.005 for the 5 millimeters either way. Yeah, and then the halfway point thing still happens. I'm just going to put my 5 millimeters either side here, 5 millimeters, 5 millimeters. So that's 0.005 meters. So my halfway point here is going to be at 0.3025. And my halfway point of this one here is going to be at 0.2975. Quite a lot harder as you get to more decimal places, isn't it? So 0.3025 meters on that side and 0.2975 meters on that side. You can think of it as 2.5 millimeters each way, or 0.0025 meters each way. Hopefully going through these examples, bear in mind these ones are getting increasingly difficult as we go down the page, but hopefully going through these will help you to tackle some of the questions towards the end of the measures and accuracy questions that I'm going to set you for homework.